All right, so I'm gonna look through the practice test. Okay, it's on WebAssign. The crazy weather has my voice kind of going and coming. I got a little bit of laryngitis, so got a peppermint in my mouth, so hopefully that'll get us through test review. Okay. Anybody have just any general questions about the test before we start looking at problems? I will give you formulas you need. From just looking back over the test review, there's really not a whole lot though that we need. I think the slope formula, and then the vertex formula for getting the vertex of a parabola, I think is about all. If we run across anything else, I'll make sure to include that. Okay. So, can't think of anything? Okay. We'll start looking at the practice test. There are a few places where I'll cross some stuff out on this that you don't have to worry about. So make sure you catch those. WebAssign won't let me just put like if we got a multi-step thing on there, it won't let me just put part of it on there. So some of it you don't have to worry about some of the steps. We'll talk about them as we get there. Okay. All right, so number one just gives us some values where we want to evaluate our function. Okay, so all that means is we take whatever number it gives us and we plug that in for x and see what we get. Okay. So on this first one, we want f of -2. Okay. Our function is x cubed plus 6x. So we'll have -2 cubed plus 6 times -2. You have to be a little bit careful with the sign here, because when we do -2 times -2 times -2, we'll get a negative. That comes out -8. And then 6 times -2, get -12. And that one we get -20. Okay. A little bit sloppy there. And then we would just do the same thing with whatever number we're dealing with. So next one's -1. So -1 cubed is -1 minus 6, and get -7. 0 is even easier. Got 0 cubed plus 6 times 0. That one is just 0. Don't worry about the fraction one. You can do it in the calculator. Get it. Or, I mean, you can do it without a calculator too. But I'm not going to throw you a fraction in there that you have to do. Okay. Questions on that one? Okay. Number 2, we got the same thing, but we've got a piecewise function. So we just need to remember how to use these things. So remember, we've got the conditions for which x values we use which piece of the function over on the right side. So like this one says, if our x value is less than -2, we use the top. For x values between -2 and 2, we use the middle. Or if our x value is bigger than 2, we use the bottom. Okay. So for the first one, let's see, we've got -5 as the x value we're using. Okay. So -5 is smaller than -2. So that means we'll use the top part. We'll use the top part. So we'll have 7 times -5. That'll give us -35. Next one's a little bit trickier. So our x value on that one is -2. -2. If you look at the middle one, it's got the or equal to bar on both of these. So this is saying we use that one if x is -2 or 2 or anything in between, we do that one. Okay? It's not going to be the top one because we don't have the equal to bar on there. Okay? So we'll use the middle one for this. So we'll have -2 plus 4, get 2. Okay. Next one, our x value is 1. 1's between -2 and 2, so again we use the middle. So we'll have 1 plus 4, get 5. Okay. F of 2 is similar to what we had to do with f of -2 because we've got the or equal to bar on the middle part. So again, we're using the middle one. Okay. So we'll have 2 plus 4, get 6. And for the last one, f of 5, finally we get something that's bigger than 2. So we'll use the bottom part. Okay. So there we'll have 5 minus 2 squared. 5 minus 2 is 3, so 3 squared is 9. Okay. Questions on that one? Just the main thing to focus on is knowing which piece to use. I've been able to figure that out. What, that part? Yeah, it would give it to you. Yeah, it could be anything in here. The rules could be anything in here, and then you just need to look over here to know which piece to use. Yeah. Okay. Other questions? Okay. Number 3. 3 and 4 were finding the domain. Remember, those are the x values that work with our function. Okay. And then we want to put our answer in interval notation. Okay. So you can go ahead and put a star by these two because there will be one like each of these for sure on the test. Okay. All right, so number 3. Remember, we really only have 2 things that we have to worry about when we're thinking about the domain. We don't want to get a 0 in the bottom of a fraction, and we don't want to get a negative inside of a square root. So number 3, the only one of those 2 things we have to worry about is the bottom of our fraction being 0. So you might be able to look at it and tell what x value would make it 0. If you can, that's fine. You know we got to leave that x value out. If not, if you can't tell, if it's something maybe a little more complicated or you just not hitting you out, then what we can do is take the bottom and set it equal to 0. Solve for x. Okay. Here we add 12 to both sides, divide both sides by 3. Okay. So the x value that would make our denominator 0 is 4. That's the x value we want to leave out because we don't want the bottom to be 0. Okay. So when we're writing our domain here, It's all real numbers except for x equals 4. So when we write that down, we have a parenthesis, start at negative infinity. And then we want to leave out 4, so we stop at 4. Have another parenthesis because we're leaving that out. That's really only like half of our domain because we want the numbers on the other side of 4 as well. So have another parenthesis with a 4. That'll go to positive infinity. And then just to glue these two pieces together, we've got that little union symbol. Remember, if we're leaving a number out, that's what our interval notation looks like. Yeah, because it said interval notation. Questions on any piece of that one? Okay. Or same type of problem, but we've got a different function. On this one, we don't have to worry about getting 0 in a denominator. But what we don't want is we don't want this t plus 5, the part that's inside of our radical, we don't want that to ever be negative. Because we only want to deal with real numbers, and if we take the square root of a negative, we get highs, complex numbers. So we want the thing that's inside of our square root to always be 0 or bigger. So this one's not too complicated. You might be able to look at it and see what would make it 0, and then anything bigger than that's okay. If not, if you can't tell, set it equal to 0. Okay. This says if our t value is negative 5, we'll get 0 in here. 0 is okay with the square root. But we always want the inside to be that or bigger, 0 or bigger. We don't want it to be negative. So any t value that's negative 5 or bigger will be okay. So the way we write that down, I think negative 5 is as small as we can use. And so we do accept negative 5. We can use negative 5. So we'll have a bracket with a negative 5. And then anything bigger than negative 5 is okay, so we can go to positive infinity. So this is like the questions on that one? Yep. 2 because anything smaller than negative 5, we've got to throw out. Because all these would give us negative numbers. But then from negative 5 up, all that works. The difference on the other one is that anything smaller than 4 works and anything bigger than 4 works. So we've got some numbers on both sides of 4. But here we only care about the stuff that's on the right side of negative 5. Yeah. It's a good question. Anything else? Because negative 5 is okay, we want to include negative 5. Because if we plug in negative 5, we get square root of 0, and that's 0, so that's okay. We just don't want to go smaller than negative 5, because then we get a negative. But if you want to include the number, use the bracket. But if you need to leave the number out, like we had to do with the 4, use parentheses. Yeah. And then the infinities always have a parenthesis. Other questions on those? Those are both good questions. Okay. Number 5, so use the vertical line test to decide if the graph is a function, if it represents a function. So remember the vertical line test. It says if there's anywhere we can draw in a vertical line that touches the graph more than once, it's not a function. If we can't do that, so if we can only touch it at most one time, it is a function. Okay? So on this one, can't really see anywhere I could draw in a vertical line that would touch it more than once. Okay? This one is a function. Okay? What about B? What do you think? That one is a function. Again, nowhere we can draw in a vertical line where it touches it more than once. What do you think about C? C is not a function, because if we draw in a vertical line, like maybe in there somewhere, gonna cross it more than once. That one's not a function. Okay. What about D? Maybe it's a little bit harder to tell on the screen, but somewhere in there. I would cross it multiple times, so that one's not a function. Okay. So if you can draw in any vertical line that touches it more than once, not a function. Okay. Questions? Okay. As long as you remember what the test says, then you're in pretty good shape there. Okay, what's next? All right. This one gives us a table of values. It says we're dealing with a linear function. Part A says find the rate of change. Okay, so remember, rate of change is just the same thing as the slope. Okay. So here's one where we would need a formula. So I would have this on the formula sheet. We want to calculate slope. Rise over run, so changing y over the change in x. Remember, f of x is the same thing as y. So if we want to find the rate of change, or we want to find the slope, we just need to pick 2 points out of the table and use the slope formula. You can pick any 2 points you want to. Okay. So I'm going to pick this one and this one, I think, because the numbers are the smallest. I'm going to call this one 0.1, this one 0.2, just so I don't get confused. My slope, I need the y from 0.2, so that's 1, minus the y from 0.1, so that's 5, over the x from 0.2, that's 2, minus the x from 0.1, so that's 0. I get negative 4 over 2, that's negative 2. There's my rate of change. Okay. And then putting it in the form ax plus b, that's just like mx plus b. Okay, so a is the rate of change, or you could call it m and call it the slope. Okay. We've already got that number, so we're going to have negative 2x. Okay, so just plug in the slope for the rate of change. Okay. And then we need b, the y-intercept. We're lucky enough on this one, this point is b. the y coordinate is. Okay? So this is the y-intercept. So we've got an x coordinate of 0. I mean, this is the y-intercept. So our y-intercept is 5. So plus 5. Okay. Questions on that one? Yeah, scroll up a little bit. Better. Okay. Right, no questions on that one? Okay, all right. Number 7, we're thinking about transformations on a graph. Okay, how it's got moved around and changed. So this one gives us y equals f of x plus 4 plus 2. So we're thinking about if we start with f of x, what would be different from f of x to this thing? And what have we done? So this plus 2 on the outside, what's that going to do to our graph? Remember? It's going to go up 2. Yep. Go up 2 units. So we can narrow it down here. Right? Let's see, one of the first 2. And then this plus 4 on the inside with the x, that's going to be horizontal because it's inside with the x. We just got to remember which direction. Is it right or left 4? That's left 4. Those are kind of have to think about them backward. Right? So that's going to be left 4 units. So the one that says 4 units to the left and 2 units upward, that's that one. Questions on that one? Okay. B part, same idea. Almost the same kind of transformation, we just got different numbers on there. So here minus 3, what's that going to do? We're going to go down 3. So it's got to be that one or that one. And then the minus 1 inside with the x, that's going to go right 1. So looks like it's this one again. Right 1 and down 3. Yep. And then with the numbers on the outside, if it's positive, it's going up. If it's negative, it's going down. Those are easier to remember because that goes with the y values easier. Anything else on that one? I think we got some more. Number 8. Okay. All right, same idea on this one. We got the plus 3 just on the end there, so that's going to be up 3. But then we've got a minus sign out front. That's going to be some kind of reflection. We just got to remember that y-axis or x-axis. So if you throw a minus sign out in front of the whole thing, it's going to take all the positives y values and make them negative. All the negatives will make them positive. So if we put a negative out in front of the whole thing, that's an x-axis reflection. And that changes top and bottom. Okay. So this one we've got an x-axis reflection and shifted up 3 units. If the x was on the inside, like if it said f of negative x, that would be an x-axis reflection where it switches left and right. Did I say x-axis? Y-axis reflection where it switches left and right. Yeah, so yeah, if it's on the outside, it flips up and down, so that's over the x-axis though. And then if it's on the inside, that switches left and right, so that's over the y-axis. And B, got a minus 3 out here, so we've gone down 3. Then we've multiplied by 2. So when we multiply by a number, that's either a stretch or a shrink. You gotta remember, if we multiply by a number bigger than 1, that's a stretch. If we multiply by a number between 0 and 1, that's a shrink. So we multiplied by 2, so we have stretched by a factor of 2. So that's going to be that one. So that's stretch 2 and then down 3. If it was like we'll multiply by 1/2, that would be a shrink. Something between 0 and 1. But anything bigger than 1 will be a stretch. Questions on that one? Okay. Number 9, we're going the other way. We got to write down what the function would look like. So we're starting with absolute value of x, and then we got these things we've got to do. So first it says shrink by a factor of 1/7. So we'll have 1/7 just multiplying the absolute value part. The shift to the left 6 units. So that's horizontal, so it's going to be inside with the x. Is that +6 or -6? +6, yeah, +6. And then we need to shift up 2. So on the outside we'll have +2. +2. And then, kind of check it, kind of work backwards. Say, okay, that's up 2, that works. That's left 6, and then that's between 0 and 1, so that's a shrink. So we can check there. Questions? Okay. Number 10, the one with a bunch of steps, a bunch of parts. On these, don't worry about the domain on any of them. We've already got the questions where we ask about the domain, so. Gets a little excessive if I ask you about the domain of everything, so. Okay. So it says f of x equals x, g of x equals square root of x. So first we want to find f plus g. So if we want f plus g of x, that just means f of x plus g of x. So f of x is x plus g of x is square root of x. If there are any like terms, we can combine those, but we don't have any like terms here, so that's all we need to do there. Okay. F minus g is very similar. We're just subtracting instead of adding. So we'll have x minus square root of x. Again, we don't have any like terms or anything to do to simplify, so yeah. F times g means we would have f of x times g of x. That'll be x times square root of x. Nothing really to do there either. Okay. And then for division, have f of x over g of x. X over square root of x, and it's fine if you leave it like that. Okay. Questions? Okay. 11 gives us two functions, and we've got two things to find. Part A says find f of g of 0. B says find g of f of 0. Okay. So on the first one, we want f of g of 0. So g of 0, g is 6 minus x squared, so we'd have 6 minus 0 squared. That's just 6, so we want f of 6. For 6, we're going to plug in the f of x. So we'll have 4 times 6 minus 5. So it's 24 minus 5, so that's 19. With me on that one. Those are not hard as long as you see how to figure out what order to do stuff in. If you're having trouble seeing what order to do stuff in, then they're confusing when you talk about it. Okay, on them? Okay, all right. So this says g of 0. That means we're going to take 0 and plug it in for x here. So then that's 6 minus 0 squared. So g of 0 is 6 minus 0 squared. When we figure that out, that's just 6 minus 0, so it's just 6. So then this says we take 6, and we're going to plug it into x here. So we get 4 times 6 minus 5. That's 19. Part B, we're just switching the order, so we've got to do that. We've got to use f first. Okay. So f of 0 means we're going to go to f and plug in 0 for x. So we'll have 4 times 0 minus 5. So 4 times 0 minus 5. So 4 times 0 minus 5 is just negative 5. So then we take the negative 5. We're going to put it in for x and g. So we'll have 6 minus negative 5 squared. 6 minus negative 5 squared. This one's a little tricky with the signs. So negative 5 squared is 25. So we got 6 minus 25. So there we get negative 19. Is that right? Okay. Question? Okay, there. Okay. 12 is another one with a bunch of parts. So we're doing composition again. Don't worry about domain on any of these. We didn't even talk about how to find domain with composition. It just wasn't, I didn't have a good question I could assign you that didn't have that on there. So the open circle means one function goes inside of the other function. Okay. So f open circle g of x means we want f of g of x. Okay. The one closest to the x is going to go on the inside. Okay. So g of x, we're told is x plus 4. So instead of writing g of x, we'll write x plus 4. Okay. So those are the same thing. And then to find f of x plus 4, we're going to plug that into f. So instead of x squared, we'll have x plus 4 squared. So here we'll have x plus 4 squared. You don't have to worry about multiplying that out or anything. Yeah, you can just leave it like that. That's fine. Is that what you asked? Okay. Oh, yeah. Okay. Next one, same thing, but the order is different. The same type of operation here. On this one, we got G open circle F. So G composed with F. So F's going to go on the inside. We'll have G of f of x. So f of x is x squared. So we'll write x squared instead. So to find g of x squared, we're going to take x squared and put it in the place of x in g. So instead of x plus 4, we'll have x squared plus 4. We're done there. Questions? And f of f and g of g, don't worry about those though. It's the same thing, it's just you're doing the same function twice, and it gets a little more confusing. So if you can do the first two, you're in good shape. Okay. Do those two. Okay. 13 says determine whether f is 1 to 1. Okay. So the way we can do that, remember 1 to 1 means it has an inverse. But the way we can test to see if it's 1-to-1 is the horizontal line test. Okay. So same idea as the vertical line test, but we use a horizontal line and it's testing to see if it's 1-to-1. So if there's anywhere we can draw in a horizontal line that touches our graph more than once, it would not be 1-to-1, which would mean it does not have an inverse. So what about this one? Think this one's 1-to-1 or not? This one's not, and it's maybe a little harder to see on the screen, but somewhere in here, if you draw in a line there, would touch more than once. I'll try to give you one that's more obvious than that. So this one is not 1-to-1. So that would mean this function does not have an inverse. Okay. Questions on that one? Okay. (14) says assume that f is a 1-to-1 function. So that means assume f has an inverse. Okay. And it says if f of 5 is 18, find f inverse of 18. Okay. How in the world are we supposed to figure that out? It doesn't even tell us the function. We don't have to know. Because remember what an inverse function does. It just switches the x's and the y's. So if f of 5 is 18, the inverse has to do the opposite. So f inverse of 18 has to be what? 5. Gotta be 5. Yeah. They just go the opposite direction. Okay, so that one's 5. Okay. B part says if f inverse, same thing's true if you start with the inverse, nothing changes there. It says if f inverse of 48 is 24, what's f of 24? 48. 48. Okay. Okay. So inverses, switch, well, switch. Switch. Okay. 15 is use the inverse function property to determine whether f and g are inverses. So what that inverse function property is that we need to find f of g of x and g of f of x. And if both of these simplify out to x, so if this one equals x and this one equals x, that means they're inverses. And it means they're inverses. If either one comes out to something different, something other than just x, they're not inverses. Okay. So find an f of g of x. Okay. That'll be f of x minus 8 over 5. So what that's saying is we take this thing, x minus 8 over 5, and plug it in where the x is, in f. So we'll have 5 times x minus 8 over 5 plus 8. And then we just need to simplify. It's not as bad as it looks, because here 5 over 5 cancels. And then minus 8 plus 8. That cancels. So all we're left with is x. Okay. And we do it in the other order. G of f of x, that's g of 5x plus 8. So we take this, 5x plus 8, and we plug it in where x is. So we'll have 5x plus 8 minus 8 over 5. Okay. This part is where the x was. And then what happens on this one? Plus 8 minus 8, those cancel. And then 5 over 5, that cancels. We just get x. So on both of these, we just got x. So that means these are inverses of each other. Okay. They are inverses. If we got something else on either one of them, they're not inverses. Questions on that one? No? Okay. All right. 16 says find the inverse function of f. Okay. If you remember these, we kind of broke these down into 3 steps. Okay. Step 1, instead of writing f of x, we're going to change it to y. Just so we don't have to deal with that f of x notation. Step 2, you remember what we do? What the inverse functions do, they switch x and y. So we're going to do the same thing. So we'll have x equals 8 minus 5 y cubed. Okay. And then now the last step we solve for y. Okay. Step 3. I'm going to subtract 8 from both sides. That's fine. Okay. Divide both sides by -5. We're almost there, but we just want y. We've got y to the 3rd power, y cubed. So what can we do to get rid of that 3rd power? Cube root, yeah. Yeah, you think you were thinking there, I think. So cube root, so we'll do the 3rd root. So we'll have, I'm going to write it over here. We'll have cube root of x minus 8 over -5 equals y. So this is our inverse function. Okay. So change f of x to y, switch x and y, and then solve for y. Okay. Questions on that one? They're so quiet. Okay. Number 17 Is the graph of f of x. We've got 5 times x minus 6 squared minus 2 is a parabola that opens, does that open up or down? Opens up. Remember how we tell that, the number out in front, and if it's positive, it's smiling, it opens up. If that number is negative, it's frowning, it opens down. This one opens up with its vertex at, okay, so the vertex, if it's written in this form, this vertex form, the vertex is at h comma k. So h is the number we're subtracting in here, k is the number on the outside. So our vertex will be at 6 comma negative 2. Kind of remember, you can take like the opposite sign of the number with the x, and then the one on the outside, you keep the sign. Okay. And then it says, and f of 6 equals, all that's saying is the same thing as this. This says f of 6 is negative 2. Yeah. So saying that points on the graph is the same thing as saying f of 6 is negative 2. This is saying negative 2 is the, would that be a minimum or a maximum? It opens up, so we've got a minimum, yeah. If it opened downward, we would have a maximum at the vertex. Yeah. We've always got one or the other, but we only either have a minimum or a maximum, and it depends on if it opens up or down. Okay. And then 18 or 19 are the same type of problem. They're just two different sets of two different functions. It says find the minimum or the maximum value of the function. That's the same thing as telling you to find the vertex. These are not in that special form where we can just read the vertex off of there. So we need, this is where we need the vertex formula. And this will be something that's on the formula sheet. So our x coordinate's negative b over 2a. And our y coordinate will be f of negative b over 2a. Okay. So as far as minimums and maximums, negative b over 2a is where the minimum or maximum occurs. And then f of negative b over 2a is the actual minimum or maximum value. Okay. So remember our, what letter's what? The a is the number with the x squared, b is the number with the x, and then c is the constant value. Okay. On this one, if we want to figure out negative b over 2a, what's our b? 8, so we'll have negative 8 over 2 times, what's our a? 2. That's negative 8 over 4, or negative 2. Okay. Then to get the actual value, we take that negative 2 and we plug it into our function. So we want f of negative 2. So we're just going to take negative 2 and plug it in for x. And so 2 times negative 2 squared plus 8 times negative 2 minus 9. So let's see. Negative 2 squared is 4. 2 times 4 is 8. You can do this in the calculator, it's fine. Minus 16 minus 9. So that's 8 minus 25. So Negative 17. So we get negative 17. Okay. And is that a minimum or a maximum? It opens up because A is positive, so it's a minimum. Okay. This tells us opens up. Okay. Questions or you need me to scroll over or anything? Okay. I'll post this on Canvas. Okay. And you'll have the screen recording too. Okay. One more, just like it, just so we got to practice more than one. Okay. So first we need negative b over 2a. So what's our b on this one? Negative 24, so if we do negative 24, I'm going to write it down like that. It'll end up being positive 24. Over 2 times a, which is 3. So that's positive 24 over 6, which is 4. And then to get the actual value, we want to find f of 4. That's 3 times 4 squared minus 24 times 4. Numbers are a little bigger on this one. Again, feel free to use a calculator. So let's see, that's 48 minus, I don't trust my brain today, so let's see, negative 24 times 4, negative 96, then minus 140 equals negative 188. So that's our value. Is that a minimum or a maximum? It's a minimum again. We've got a positive 3 out front, so it opens upward. That's a minimum value. Okay. Questions? Okay. If you do have questions or got anything you want me to take a look at or anything like that, we got plenty of time. I'll hang around and do that. Okay. I'll take this and put it on Canvas, and you'll have the link to the review video as well. Okay. And then I'll give you slope formula and I'll give you vertex formula. Okay. All right. See you on Thursday.